Okay, so in previous session, in previous video, I just solved one numerical on tolerance calculation where we have taken example of turning operation. Now we are moving further with a new term of deviation. What is meaning of deviation? If you look, then as per definition, deviation is difference between actual size and basic size. Now basic size is as per design, as you know, this term we have already discussed in very first session on this limit fits tolerance. So basic size is the design dimension which actually we want as per our design calculations, but as we know we need to give some tolerance, some permissible deviation, and due to that you get lower limit and upper limit. So lower limit and upper limit, within that you will be having actual size. Clear? So algebraic difference between actual size and basic size. Then as you are giving tolerance, then you will be having two limits, lower limit and upper limit. So here you can see this is suppose our basic size line, which is written as a 0 line. Now you can consider this as a tolerance zone. This rectangle is indicating tolerance zone. This line is indicating lower limit and this line is indicating upper limit. So if dimension within these two lines, then that is acceptable. Okay. So now you will be having possibility. One is a maximum possible dimension, upper limit, and second is least possible dimension, that is called as a lower limit. Okay. So two limits. That's why those two limits, they are actually representing possibility of two actual dimensions. Okay, so here algebraic difference between actual size and basic size, that is called as a deviation. So two limits, that's why you will be having two deviations also. So that's why here written upper deviation and lower deviation. What is upper deviation? So as per this definition, upper limit minus basic size, that is called as the upper deviation, which is represented by letter capital letters, that is ES. So capital E or small e, that is used for deviation, and here this S, letter S, is used for deviation, upper deviation. Okay. Similarly, if you are taking difference between lower limit, here lower limit and basic size, then that is called as a lower deviation. So for lower deviation, again for deviation letter E is used, alphabet E is used, and for lower deviation I is used. Okay, so this is abbreviation for deviation. Clear? If you are talking about upper deviation of whole, then capital ES is used. If you are talking about upper deviation of shaft, then small es is used. Small letters always for shaft feature, means all the external feature, and capital letters always used for whole, all the internal feature. This is uniform for this entire chapter. Okay, so if you are talking about lower deviation of whole, then capital EI is called as a lower deviation of whole. If you are talking about lower deviation of shaft, then small ei is used for lower deviation of shaft. Okay, so this terminology I think clear. Now if you look this diagram, then basic understanding of deviation is what? This is what we discuss about how to find out numeric value. But what is the actual meaning of deviation? Actual meaning of deviation is how far tolerance zone is from basic size line. That is called as a deviation. Means if you look here, this is my basic size line, which is written as a 0 line, because 0 line and basic line both terms are used. So 0 line is nothing but basic size line. So this is basic size line. Now how far? If you look here, this much of distance away, I am indicating tolerance zone. Yeah? So actually meaning of deviation is how far you are locating tolerance zone of component with respect to basic size. This is meaning, actual meaning of deviation. Similarly, if you see here, then how far I am locating deviation from 0 line. But here if you see both these two tolerance zones, then this tolerance zone is above basic size. So this deviation is positive. You can see here this sign is positive, and this tolerance zone is below basic size. Then deviation in this direction, downward direction, is negative. Okay, so now if you look, let us try to understand this diagram. This is tolerance zone, this width is tolerance zone. For how to find this width, you need to understand that you need to refer our previous session about that example of tolerance. So from there you can understand how to find width of this box, which is actually tolerance. Now if you take difference between lower limit and basic size, then you get this much of distance. Then this is called as a lower deviation. You can see here, this is called as a lower deviation, and this lower deviation would be positive because lower limit is more than basic size. Similarly, if you take difference between upper limit, positive upper limit, and basic size, then this much of distance you get, this much of numeric value you get, then this is upper deviation again, because you have taken difference between upper limit and basic size. So if your tolerance zone is on positive side from basic size, then you get both the deviations as a positive. But now if you look at a tolerance zone below zero line or below basic size, means dimension or the limits, both the limits, they are negative with respect to basic size. Clear? So now if you again take difference between, this line is indicating upper limit. So if you take difference between upper limit and basic size, now you can clearly see here, basic size is more than upper limit here, because we have placed tolerance zone below basic size. So now you get difference negative. So this difference you get negative, and that's why it is on negative side. Okay, so here you get upper deviation. This dimension is upper deviation, which would be negative. Similarly, now if you take difference between lower deviation, this line, lower deviation, and basic size. Now again, lower deviation, lower limit minus basic size. Now again, lower limit is less than basic size. That's why again you get this dimension as a negative, and that's why it is placed on negative side. Okay, so now I think clear about a positive value and negative value of deviation. Clear? Now we are moving further. Now this is indication for hole. If now you can see here again, this vertical axis is indicating deviation, and this line is indicating, zero line is indicating basic size. Now if your manufactured dimension is above basic size, then this is what called as the amount of deviation. This is called as the amount of deviation. Let me give you one example. Suppose I want hole, cylindrical hole with diameter 50 mm. And suppose, so this line is indicating 50 mm dimension. This line is indicating 50 mm dimension. Now suppose if you get hole manufactured with 51 mm, then this line is indicating 51 mm. Okay, so you get 51 minus 50, 1 mm positive deviation. But suppose by chance, if you manufactured hole with 50 mm diameter, then actual dimension is overlapped on basic size. So this indicating both are overlapped. But now suppose if you produce hole under size, means I want basic size 50, but suppose I have produced actual hole of 49 mm. So this line is indicating 49 mm. So now if I take difference as per the deviation, I cannot sweep terms. I need to always take limit first minus basic size as per this previous definition. It's an algebraic difference. So always you have to keep limit first minus basic size. So it's a sign sensitive. That's why 49 minus 50, then you get minus 1. So this minus 1 in negative sign. Okay, so this is what the understanding of sign of deviation. Now we move further. Now next term is fundamental deviation. What is fundamental deviation? Fundamental deviation, because if you consider whole, then whole is having two limits, upper limit and lower limit. So if you take difference between upper limit minus basic size, then you get, means if you consider this as a tolerance zone of whole, we have considered whole tolerance zone above basic size. So both the limits, this is lower limit line and this is upper limit line of whole, both are positive because both are more than zero line. So now if you take difference between lower limit of whole and basic size, then this is called as a lower deviation, which is indicated by capital EI. E later is used for deviation and I later is used for lower deviation. And capital letters, both capital letters E and I, they are used for whole feature, internal feature. That's why it is written here, whole feature. Clear? So this is called as a lower deviation. Similarly, now if I take difference of upper limit minus basic size, difference between upper limit and basic size, then I get this much of distance. So now it's a difference between upper limit and basic size. That's why this is called as an upper deviation. So again, upper deviation would be positive. Okay, but now if you consider whole tolerance zone on negative direction, means we have considered both the limits lesser than required basic size. Means for example, I want basic size of 50, but I am giving limit 49 and 48. So this line is indicating 49 with respect to 50 size. This is 50 mm line. This is 49 mm line and this is 48 mm line, suppose. Now if you take difference, 49 means the upper limit and basic size. So 49 minus 50, I get -1. So that -1 is called as a upper limit. Similarly, if you take difference between lower limit, lower negative limit and basic size, means lower limit is 48. So 48 minus 50, then you get -2. So in negative direction you get capital EI. Both are for whole, that's why they are written as a capital letters. So now let us try to understand what is fundamental deviation. So out of two deviation, smallest is called as a fundamental deviation. If you look in this representation, EI is smaller than ES. You need to only consider numeric value, not the sign now. So EI is less than ES. That's why here EI is called as a fundamental deviation. But if you look here, if you have kept tolerance on negative direction with respect to basic size, then you can look here, ES is smaller than EI. So here this ES, upper deviation, is called as a fundamental deviation. Okay, so it's a relative term actually. Fundamental deviation is a relative term. It's not absolute term. Out of ES and EI, lesser value is called as a fundamental deviation. Okay, so I hope it is clear what is fundamental deviation, because later, similar to the tolerance grades, we are having fundamental deviations grade, standard fundamental deviation grades as per Indian standard. Okay, so now we are moving further. So I was talking about this. So here you can see these alphabets, they are indicating different fundamental deviation grades. You can see here A, B, C, C, D, D, E up to capital H, then further J, S to capital N, further capital P to ZC. So total 28 grades, total 28 alphabets are used. So each alphabet, this A is indicating some fundamental deviation, B is indicating some other fundamental deviation. Okay, so this, as I told you, capital letters, they are used for whole feature. So this capital A, capital B, capital ZC, they are indicating fundamental deviation, standard as per Indian standard, standard fundamental deviation for whole feature, internal feature. Similarly, if you look here, same alphabets, but now in lower case. So small a, small b, small c, up to small zc, again 28, both are same. Clear? But here lower case is used, so they are the fundamental deviation for shaft. Okay, so these are the alphabets. Now let's see graphical representation. So that will give you actual feel. What is the meaning of capital A, capital B and capital C? So here you can see this is graphical representation of whole fundamental deviation. So this is your deviation axis, vertical axis is deviation axis, and this horizontal zero deviation line is called as a basic size. Okay, so if you look here, this A, B, C, D, you are moving towards H. Then as you are moving towards H, these all rectangles, this height of rectangle, they are representing tolerance value actually. Okay, so as per the meaning of fundamental deviation is representing how far tolerance zone with respect to basic size line. So here you can see capital A, capital B, as I am moving towards capital H, my tolerance zone is coming more and more close to basic size line, and here you can clearly see this H. Then for H, tolerance zone exactly starting from basic size. Is it clear? So up to A to G, we have placed tolerance zone some distance away from basic size in positive direction. But capital H is representing tolerance zone is exactly starting from basic size. And as you cross this H, then from ZS to ZC, tolerance zone is again moving away from basic size line, but now it is in negative direction. Clear? And as we have used here capital letters, so this is about whole fundamental deviation. Clear? Now, if you consider this A to H, because it is representing fundamental deviation, as possibility of fundamental deviation 2, 1, it can be lower deviation as a fundamental deviation or upper deviation as a fundamental deviation. So if you are using capital A to capital H later, then here you can see this EI means lower deviation of whole is considered as a fundamental deviation. Please remember, so this capital A to capital H, then lower deviation of whole is considered as a fundamental deviation. What is lower deviation of whole? It's a difference between lower limit of whole and basic size. So here if I'm considering this D, capital D later, then this height is tolerance value. To understand how to find this height, as I told you, you have to refer previous video, that will give you idea. So this height is tolerance of whole. Then this lowest most line is called as a lower limit. This uppermost line is called as a upper limit. So as I told you, if you take difference between lower limit and basic size, you get lower deviation. And if you take difference between upper limit and basic size, then you get upper deviation. And what is fundamental deviation? If you look in this D, capital D, fundamental deviation, then upper deviation and lower deviation. Then lower deviation always smaller than upper deviation. If you are working in range of capital A to H, because in previous slide also I have represented same. If you are considering tolerance on positive side, means if you are putting tolerance above basic size in the positive direction of basic size, then lower deviation always, smaller than upper deviation. And that's why lower deviation always considered as a fundamental deviation. So if you are referring capital A to capital H, then lower deviation is called as a fundamental deviation. I hope it is clear to you. Now if you move further, after crossing H, capital H, remaining later JS to ZC, then upper deviation, here it is shown, this capital ES is fundamental deviation. Yeah, and that is what again we discussed in previous slide. If you consider tolerance on negative direction, means tolerance below basic size line, then always this ES would be lesser than EI. If you consider this Y, then this is upper limit line and this one is lower limit line. So always if you take difference between upper limit and basic size, then you get ES. and you take difference between lower limit and basic size, then you get EI. Then ES always lesser than EI. Then for JS to ZC, always ES is smaller than EI, and that's why ES is considered as a fundamental deviation. Okay, and what is ES? ES is representing upper deviation. So upper deviation is always considered as a fundamental deviation. Clear? Now similar representation for shaft. Now this is for hole. Now similar representation for shaft, but now if you look, diagram is flipped. In previous case, capital A to capital H, they are on positive side, but if you look in this diagram, then for shaft feature, small a to small h, they are on negative side. Otherwise it is same. If you look this two, this diagram and this diagram, both are mirror image of each other. But here this capital A to capital H, they are on positive side. But here small a to small h, they are on negative side. Clear? So here, if you consider negative, then as we discussed earlier, if you consider tolerance zone on negative side, then always upper deviation is smaller than lower deviation. You can clearly see in this small e later. This representing ES. Similarly, if you consider this arrow, this much of arrow for E, then this difference, this lower limit of shaft minus basic size, then you get this much of dimension. So EI greater than ES, and fundamental deviation always smaller deviation. So ES is considered as a fundamental deviation. So if you are taking small a to small h, then upper deviation always smaller than lower deviation of shaft, and that's why upper deviation is considered as a fundamental deviation. So small ES is considered as a fundamental deviation. So if you consider this small h, it's a special case. As per small h, tolerance zone exactly starts from basic size. Upper limit of shaft is equals to basic size, and then after you add tolerance value and you get lower limit of shaft. After crossing small h, if you see here J to JS to up to ZC, now again tolerance zone is shifting away from basic size, but now it is on in positive direction. If you go in positive direction, then this is, if you consider this V later, V fundamental deviation, then this distance lower limit to basic size distance is EI, lower deviation. But again, if I indicate upper deviation of this V later, then this representing this upper limit, this is upper limit minus basic size, then you get this red arrow dimension. Then ES always greater than EI if you consider tolerance on positive side. Then small EI is smaller than small ES, and that's why small EI is considered as a fundamental deviation. Okay, so after crossing small h, if you take K, M, H, P, R, S, T up to ZC, lower deviation is considered as a fundamental deviation. I hope it is clear. So this is for shaft. Now if you see in this diagram, this will give you clear indication of flipped images. So here you can see both the tolerance zone are indicated in same image. Both the deviations, they are indicated in same image. Then here you can see this is basic size line. If you are talking about whole feature, then capital letters. So you can see here capital H to capital capital A to capital H. Then tolerance is moving towards basic size, and please note lower deviation of whole is considered as a fundamental deviation. After crossing H, upper deviation of whole is called as a fundamental deviation. But if you consider shaft, then mirror image of this. So again this line is representing basic size. जितना यहाँ से A दूर है, कैपिटल A दूर है, उतना ही यहाँ से स्मॉल a दूर है, but this is in negative direction and this one is in positive direction. Clear? But now if you represent small a to small h, if you are talking about shaft fundamental deviation, then small a to small h letters, they are indicating upper deviation of shaft as a fundamental deviation. Please note this. This one is very much important for our further discussion in limit fixed order. So upper deviation is called as a fundamental deviation. After crossing small h, small js to small zc, lower deviation is considered as a fundamental deviation for shaft. Okay, so we keep up to this in this video. I hope it is clear to you about what is deviation, upper deviation, lower deviation, upper deviation, lower deviation for shaft and hole, then what is fundamental deviation. Okay, so we keep up to this in this session.